All right, we're back. We are on page 4 of notes 14 of Calc C, and we're talking about the logistic differential equation. You're just going to memorize it. You're going to know where the point of inflection happens. You're going to know that the curve is going to be increasing concave up and then increasing concave down. Or if you start above the carrying capacity, above the limit, then the curve is going to be decreasing. You got to know the range. These are all the common things that you're asked about. You're mostly asked about the limit in my experience. Point of inflection is definitely fair game though, so know that. And also they'll say like, what is the population when the population is increasing the fastest? That's like a trick way of asking you what's the point of inflection. So make sure you know all those things. And then it's the form that really matters, right? So this is dp dt. I am never going to survive working with these decimals, I don't think. So I'm going to change this to like 5p over 100 minus 5p squared over, I think, 10,000, right? It'd be over like 10, 100, 1,000, 10,000. Yep. And now I'm going to factor this, dp dt, because I need a 1. So I have to take out like 5 over 100p. And then I have 1 minus. So I took out 5 and 100. So this leaves me with p over 100. And if I multiply this and this, I definitely get 10,000. So we rearrange it. We rearrange it because our goal, our objective is to get this, because once we have that, we can identify that K is 5 over 100, or I'm just going to use 1 over 20. And that L is the thing underneath P. So it's 100. And then we also are given that P of 0 is 45. And then all we have to do is solve it and graph it. This is nice. This is a nice question. So we need to calculate A, which is L minus Y0 over Y0, 55 over 45. Do I want to divide that? Yeah, 11 ninths. So our solution, P of T, is going to be L, which is 100. 1 plus A, which is 11 over 9, that's fine. E to the negative 1 over 20 t. That's our solution. And we have it memorized, and that's how you're going to do it. You're not going to derive it every time. That's insanity. Because deriving the solution is like not super easy. It's not super hard, and it's easier with numbers than it is with like the generic constants and everything, but it's partial fractions. Kind of an ugly-ish partial fraction problem. You don't want to be dealing with that. All right, initial condition is 45 and the limit is 100. These are probably by ones, but I can't even tell where they are. It's 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, slope fields tend to like look horizontal before they're actually horizontal, because like, I mean, a slope of 0 versus a slope of 0.00001, you can't really visually tell. That's why it sort of looks that way to begin with. So what do we say? 10, 20, 30, 40, 50, 60, 70, 100. We need 45, so I should have marked 50, I guess. 10, 20, 30, 40. Okay, 45 is like here. Super close to the point of inflection. So we're going to go like increasing concave up to increasing concave down, like really, really quickly. And then maybe I should have dotted in the limit. You never quite get to the limit according to the model, which is fine. I mean, mathematical models are like that. In the real world, might you get there? Absolutely, but not according to the model. So this, I think we answered it. Let's see what's next. 1991, man, back in the day. I think Nirvana was big, potentially. That's what, I don't know. I'm still wearing flannel, so there's that. Let's see. So 1991, FRQ BC6. Certain rumor spreads through a community at this rate, which is the way we want it to look, because it already has a 1, and that's like our go-to first check. That's a 1, so we're good to go. Why is the proportion of the population? So a proportion of a population is going to be between like 0 and 1. And I think that's important to understand. What proportion of the population has heard the rumor when it is spreading the fastest? Okay, so if we rewrote this so it looked a little more like how maybe we want it to, it would probably look like 2y and then 1 minus y over 1, right? So the limit is 1. So then I want to say since the limit as t approaches infinity of y is equal to 1, 1/2 of the population has heard rumor. I don't want to write this whole thing, but I will. When it is spreading. It's like, I'm always torn between skipping things because I don't want to spend my whole life making these videos, and not skipping things because I want you to have perfect notes that you can study and reference and get a 5 on the AP exam. You know, so I'm torn between those things. But I try to default to the better option. If at time 0, 10%, so 0.1 of the population heard it, so that we're being told that y of 0 is 0.1. That's our initial condition. If you go back here, you can see that k is equal to 2. And we already figured out that L is 1, which kind of makes sense because eventually everyone will have heard something. We need to calculate A. So it's 1 minus 0.1 over 0.1, which is 0.9 over 0.1, which is just 9. So is it y? Yeah, y. Why are we calling it y? Whatever. Y is L over 1 plus A e to the negative k t. That's it. All right. At what time is the rumor spreading the fastest? So we need to set this equal to 1/2 and solve. So, and also, I mean, I think that we know that it's going to be the natural log of 9 over 2, but let's do it. So 1 over 1 plus 9 e to the negative 2t is equal to 1/2. So 1 plus 9 e, you can see like the math working out, right, as to why it always works out that way. Subtract 1, divide by 9, e to the negative 2t is 1/9. Natural log gives us on this side negative 2t. Natural log of 1/9. Divide by negative 2, bring the exponent up. We've done this multiple times, so I'm just going to jump to this. Okay, so this would be my answer. Then I would probably write a sentence. I think I would write, all right, the rumor is spreading. It's like I always say, I would write a sentence, and then I hear the people in my head saying, like, what sentence would you write? Rumor spreading the fastest at t equals the natural log of 9 over 2. Whatever's, minutes, seconds, somethings, I don't know. It doesn't have units, so who knows? All right, so that is page 4. That's a free response question, and it's not so far out of left field. I mean, like you could easily see a question like this on your AP exam, I think, even now, like 30 some years later. All right, so I'm going to end this here, and I will be back in the next video to do some more.